In chemistry, one of the really important things to be able to determine is if a substance will be soluble in water. So will it dissolve in water and break apart into its ions? So we have these solubility rules. They help us. Then we also have something called the solubility table or the solubility chart. And we can use this as well to figure out if something will dissolve. So in this video, I'd like to look at each rule as it relates to the chart. And that'll help you really remember what's going on. So let's start out with the first rule. Group 1 elements. So when we go to the periodic table, we look at the elements in group 1, lithium, sodium, and so on. They are soluble. So as we look down, here's potassium. That's one of the group 1. If you look at this, every one of these has an S. So potassium compounds with potassium like KNO3, K2SO4, they'll be soluble. Same for sodium. Find sodium here like NaCl or NaBr, Na3PO4. All of these are soluble. So the first rule, group 1 salts, they're going to be soluble in dissolvent water. The second rule says that compounds with NH4, the ammonium ion, they're soluble. Here's the ammonium ion. And as we go across, we have an S for almost everything. We have one small exception here. If it has NH4, like NH4OH, NH4Cl, it's going to be soluble. Compounds with ammonium, they're soluble. When we have compounds with the nitrate ion, they're generally soluble too. So here's the nitrate ion right here. We have an S for all of these. So if you had something like CaNO3 or FeNO3, that would be soluble. Nitrates are soluble. When we're talking about chloride ions and bromide ions and iodine ions, in general, they're soluble. We go down here, we see almost everything for the chlorides and the bromides, they're going to be soluble. So any of these combinations here, CuBr2, FeCl3, those are going to be soluble. There are some exceptions though. One of the exceptions is silver. So if we look at silver here, we can see silver bromide, that's insoluble. That won't dissolve, it'll be a solid. And silver chloride, that's also insoluble. Just a few more rules. Most sulfates are soluble. So here's the sulfate ion, and as you look down, we have mostly S. We do have some SS. That means it's slightly soluble. We treat that as insoluble. So if we look at the exceptions here, calcium, we go across, that's slightly soluble. If we look at silver, right here, we go across, that's slightly soluble as well. So in general, when we look at the sulfate ion, it's usually soluble with a few exceptions. I'd remember calcium, silver, and lead. When we have OH, the hydroxide, right here, most of these are insoluble with a few exceptions, but we know these exceptions. The ammonium ion and group 1 ions, we said those are always soluble. So our ammonium, here is potassium, and here's sodium. Those are all soluble, but we already know that. The other compounds, like FeOH2 or CaOH2, they're going to be either insoluble or slightly soluble. Two more rules. When we have carbonates here, they're mostly insoluble with those same exceptions of group 1 elements and the ammonium ion. Most compounds with the phosphate ion are insoluble as well, like AlPO4. With the exception, the same ones we've seen before, group 1 like sodium, potassium ions, and then the ammonium ion. My recommendation is that you memorize these general solubility rules. That'll let you move a lot quicker on exams and when you're studying. But understand these rules, they're really just condensing the trends that we're seeing on the solubility chart. And that chart, that was made up by doing a lot of different experiments and observing what happens. This is Dr. B with the solubility rules and the solubility chart, how they're related and how to remember both of them. Thanks for watching.